Hello everyone. Okay, this is section 6.4. So before I start doing this lecture, I just want to remind you guys a few things one more time. The lecture thing I will be doing won't be a detailed lecture. It will be basically over a few examples. So you guys still want to watch the Alex videos, like I said in the email. Um, so yeah, my lecture won't be a detailed lecture. I will just do few examples to just to give you guys give you guys an idea how the things would look on that particular section. So yeah, so in this section, it's basically it's about addition and subtraction of radicals. So radicals is a equation which is basically a root form, something like this. So I've started about the root on my previous lecture, so you definitely want to watch that first. Okay, so on this one, we will be seeing addition and subtraction of an equation which is going to be in this form. So let's say, let's start with easy problem. So let's say the first one, let's say 4 square root of 5 minus 2 square root of 5. All right, so here we have a minus and we need to subtract these two terms. So this is basically similar to what we have done before. So let's say if we have 4x minus 2x is, well, we can subtract these two because we said these two are like terms, right? Because we have x and x. So 4x minus 2x is, we just subtract 4 and 2, so we say 2x, right? So we have, well, we need to use similar idea here. So 4 square root of 5 minus 2 square root of 5, well, we have square root of 5 and square root of 5, so we can say in this case, we can say these two are like terms. So this is just 2 times square root of 5. All right, clear? And so let's say if we have square root of 7 plus square root of 7, well, these two are basically like similar to like x plus x is 2x, right? So again, this we can say 2 times square root of 7. All right. So number 3, let's say if we have now 4 times cube root of 4 minus cube root of 32. All right, so the only time you can combine two things is when if we have a like terms, right? So in this case we have square root of 7, square root of 7, so that's why we said 2 times square root of 7. But in this one now we have cube root of 4 and cube root of 32, so we cannot just combine these two at this point, right? So what we can do here is, now we can change actually, or we can change these to basically this form, or cube root of 4 form. So if we can make, or if you can make alike terms, then in that case you can combine these two. So what we can do here with this, let's write here what we can do here with this. Cube root of 32 is, cube root of 32 is also same as cube root of, well, 32 is also 16 times 2, or 16 times 2, well, I don't think it's going to work because we cannot take cube root of 16 and cube root of 2, so that's not going to work. So let's say cube root of 8 times 4, right? And the reason I'm doing 8 times 4 is I can take the cube root of 8, right? Because after this I can break this into two terms, cube root of 8 times cube root of 4, which gives, well, cube root of 8 is, well, it's cubed, right? So cube root of 8 is 2 times cube root of 4. Well, it's not 2. If we have square root of 4, then it's 2, but cube root of 4 is, well, we get some decimal number, so we don't want that, so we just want to leave it like this. And also that way we have cube root of 4 here, cube root of 4 here, so that way we have a like terms, right? So from here we can now say that 4 times cube root of 4 minus, so cube root of 32 is also this, so cube root of 32 is 2 times cube root of 4. So this way we have now like terms. All right, so now we can just subtract 4 and 2, which is 2 times cube root of 4. All right, so this way we can get the answer. So if you see whenever you see non-like terms, then try to make it a like terms. So that's what I did. So I made a like terms by doing these things, and then I combined two terms, right? So yeah, so you definitely need to know these kind of problem. And let's do another one. Let's say the problem is 9 times square root of 12 plus 2 times square root of 27. All right, so again, here we don't have a like terms, but we can try to make a like terms. So let's see what we can do. So here it's now square root, right? So square root of 12. So square root of 12, well, 12 we can also say 4 times 3, because 4 times 3 is 12. And you can split this into two terms. So square root of 4 is 2 times square root of 3. Right, so here what we can do is we still have this 9, so 9 times 2 times square root of 3. Plus, now for 27, square root of 27 is also, we can say 27, well, since there is a square root, so it looks like I can say 27 is also 9 times 3, right? Because 9 times 3 is 27, and we can also take the square root of 9, which will give square root of 9 times square root of 3 is, the square root of 9 is 3 times square root of 3, right? So again, now here we can say 2 times, now we have 3 times square root of 3. All right, so now this way we get 9 times 2 is 18, so 18 times square root of 3 plus 3 times 2 is 6 times square root of 3. Now this way we have a like terms. All right, so once we have a like terms, then we can combine these two, right? So 18 plus 6 is 24 times square root of 3. All right, so yeah, that's another problem. And let me do one more problem with variables. So this is number 5, right? Yeah. So let's say now if we have 50 times, let's say, x cubed minus x times 32 times x. All right, so now we can, well, we need to combine these two, or basically here we need to subtract these two, right? So the only time, like I said, only time we can do that is if we have like terms. All right, so let's try to make like terms here. So let's just work on this one. So we have square root of x to the power 3. All right, so this one we can also split this into two parts. So square root of 50 times square root of x squared, x cubed. This is cube, x to the power 3. All right, so now here 50 we can also say 25 times 2, so square root of 25 times 2. And if you go back to my previous lecture, what we can do here with this x to the power 3 is, since we have square root, so square root has the index of 2. So what we can do with this x to the power 3 is we can say x to the power 2 times x to the power 1, or we don't have to write 1 on the power, so it's just x. All right, so basically when we combine these two, because since these two have same base, so if it has same base, then we can combine these to a single base and just add the power, right? So this is x to the power 3. So now after this, what we can do after this is, again, we can split this into, or basically we can split the whole thing. In this case, we can split this into 4 terms, right? So square root of 25 times square root of 2 times square root of x squared times square root of x. All right, so now from here, square root of 25 is 5, square root of 2, square root of x squared is, well, I think I have done these things in my previous lecture. So square root of x is basically x to the power, whatever we have inside the root, x to the power 2. And since the index here is 2, so we divide this by 2, right? And times square root of x. So this gives, this is just 1 on the power, so 2 over 2 is 1. So 5x times square root of 2 times square root of x. All right, now since, well, this one has the square root, this one has the square root, so we can basically combine these again to a single square root. So 5x times square root of 2x. All right, so that's what we get from the square root of 50 times x to the power 3. All right, now let's look at another one, this one. So this one is x. So this one is x times 32x, or square root of 32 times x. So again, in this one, we can split this into, I guess, in this 3 terms. Yeah, we can split this into 3 terms. So now after this, x times 32 is also 16 times 2, right? Because since there is a square root, so we can take the square root of 16, right? So 32 is also 16 times 2, and still have the square root of x. And here, now if we split this into 2 parts, we get square root of 16 times square root of 2. So square root of 16 is just 4. Square root of 2 times square root of x. All right, now we can arrange this 4 times x, 4x, and square root of 2, square root of x, just like I did here. We can again combine these to a single square root of, or single square root. So now, okay, now when we see these two, we have same, well, basically we have like terms, right? These are same thing, right? So like So this one is this. So now when we are combining these two, so we have square root of 50 times x to the power 3 is 5x times square root of 2x minus, and we said this whole thing is now this, right? So this is 4x times square root of 2x. All right, so since these whole thing are same, so we can say now these two are like terms. So now we just have to subtract 5 and 4. So 5 minus 4 is just 1. So that means we're just gonna have 1 times x to the x times square root of 2x. All right, so you don't have to write 1. So basically you can just write x times square root of 2x. All right, so that's all I have for this section. So like I said, you definitely want to watch the Alex videos whenever you're doing your homework problem in there. All right, so that's it for this section. Thank you.